Hello and welcome to a lesson on trig with angles in any quadrant. I'm going to start off with a warm-up, so you should pause the video and do the warm-up yourself, and then you can unpause and skip it if you want, or follow along as I do it. So first we got to convert all these things to radians. So the real way is to multiply by 180 divided by pi. That's going to be the real conversion. You could also just replace the pi with 180. Or you could do what I hope you started to do, which is to memorize these three because they are the most basic ones. Okay, so pi over 6 is 30, pi over 4 is 45, and pi over 3 is 60. Now it wants us to find sine, cosine, tangent of pi over 6, of pi over 4, and of pi over 3, aka of 30, 45, and 60. So I find it useful to draw a little reference triangle for that. So here's my little reference triangle for 30. Here is my reference triangle for 45. And here would be my reference triangle for 60, which I don't officially need to do because I have that in the first triangle way over there, but I like it because then my opposites and adjacents are in the same location for all three of these different triangles. Makes it a little easier to figure stuff out. So sine will be 1/2. Cosine is going to be the square root of 3 over 2. Tangent would be 1 over the square root of 3, which we can't leave. We have to make it the square root of 3 over 3. Sine pi over 4 is officially 1 over the square root of 2, but we're going to rewrite it as square root of 2 over 2. Same thing with cosine. It will be a square root of 2 over 2. And tangent of pi over 4 is just 1. Sine of 60 is going to be square root of 3 over 2. Cosine of 60 is 1/2. And tangent of 60 is going to be just the square root of 3. Some little connections I want to kind of notice here, right? So sine of 30 is going to be the same thing as cosine of 60. We have sine of 60 is the same thing as cosine of 30. And then we have that the sine and cosine of 45 are both going to be the same. And that should kind of make sense to you because an isosceles triangle, the opposite and the adjacent are the same length. So just some things that point out that might make it a little easier to remember these 9 different trig values for the main things, 30s, 45s, and 60s. Right down here, they want us to find the exact value of this. So we have sine squared 40 degrees plus cosine squared 40 degrees over tan 45. And so the first thing that jumps out for me is that we don't know 40 degrees. That's not one that we know without a calculator. So there must be some other thing that's happening here. And if I don't read the angle out loud, it makes this one a little bit easier. This is literally saying sine squared plus cosine squared, which we know always equals 1. So this is really 1 over tan 45. And so there's lots of ways of figuring this out, but essentially we just figured out that tan of 45 is going to equal 1. So this is just going to be 1 over 1, which is 1. I also just want to point out that we could have written this as cotangent 45 because 1 over tangent is cotangent. And we would have ended up with the same exact answer, just so you know. All right, here there are 2 main ways to solve this one. One is you actually just figure out what sine squared of pi over 6 is, and you do all this algebra. The other way is that whenever you have, let me use the highlighter for that, whenever you have a trig function squared and then addition or subtraction, especially with a 1 near it, you should be thinking of Pythagorean identities. So we know that sine squared theta plus cosine squared theta always equals 1. Well, if I just move that sine squared to the other side by subtracting it, I get that cosine squared theta will equal 1 minus sine squared theta. And that's actually what I have right here. So I can rewrite this as cosine squared of that same angle, pi over 6. And then it's over the sine squared of pi over 6. From here, what I might do is say, hey, cosine over sine, I know that that's actually cotangent. So let me just rewrite this as cotangent squared of pi over 6. And then I need to figure out what this is. So little notes to myself, cotangent is really tan and pi over 6 is really 30. So in my brain, I'm going to figure out what tangent of 30 degrees is, which I've already figured out. It's way over here, is this guy, okay? So I know that this is going to equal 1 over the square root of 3 or rationalized square root of 3 over 3. I'm going to choose to use the unrationalized one. It doesn't actually officially matter here. But when I go to do cotangent, I'm going to take that 1 over the square root of 3 and I'm going to flip it because tangent is 1 over the square root of 3. Cotangent will be that flipped upside down. So I'm going to take this guy way over here and I'm going to flip it upside down and I'm squaring it because it's really cotan squared. And so that's just going to equal 3. And again, you could have done that by doing 1 minus sine squared of pi over 6 and figuring out what that is, dividing it by sine squared of pi over 6, whatever that is, and you should end up getting 3 either way. Alrighty. So now we get into the real stuff that is, all the super fun stuff. So we have let theta be any real number. So theta is no longer an angle, it's a number, a real number, which means it can be anything but not i's. And we're going to let p be some random point that corresponds to the theta value when a number line is wrapped around a circle. So basically we're taking a straight line, imagine you had like a string, and then we're wrapping it around in a circle. So we can basically line up the real number line, right? All the little tick marks on a number line, we can end up lining them up with a circle. So that's a little confusing to think about. So what we're going to do is first just throw a point somewhere on this circle. I'm going to put it in quadrant 1. It can technically be in any quadrant. So there's my little point, x, y. And then I'm going to connect to the origin. And I know that in a circle, that's a radius. So I'm going to let that be r. Now, the way that points work is if I'm at the point xy, it means I went over x and I went up y. And so now I have a little right triangle here with side lengths of x, y, and r. And then what this theta value, letting the point correspond to theta when a real number line is wrapped, blah, 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 is we let that be this little angle that's formed right there with the positive x-axis, okay? So let's just talk about what sine, cosine, and tangent would be in this little triangle real quick. Okay, so I'm going to do sine of that theta value would be opposite over hypotenuse, so it would be y over r. Cosine of that angle would be adjacent over hypotenuse, so that would be x over r. And then tangent of that angle would be y over x, opposite over adjacent. Now, what I'm going to do is I'm going to say, hey, what if I just let r equal 1 right now? Okay, and this is where people who learned this last year with the unit circle, that's what this is kind of mirroring. We're just not going to think about it in terms of the unit circle. So, but that's essentially what we're doing. We're saying that this is a, quote, unit circle because the radius is 1 and 1 is our unit when we're counting. But if I let this equal 1, then sine theta is now just going to equal y. Cosine theta is now just going to equal x, and then tangent doesn't change. It's just y over x. Okay? So using these little definitions here, that sine is a y value, cosine is an x value, and tangent is y over x, which makes sense because tangent's sine over cosine. So sine is y and cosine's x. Then tangent, which is sine over cosine, will be y over x. So that should make a tiny bit of sense. We can start figuring out some other things here. So first thing I want to pay attention to is how points work. So in the first quadrant, x's and y's are both positive. In the second quadrant, the x values are negative, but the y values are positive. In the third quadrant, everything is negative. And in the fourth quadrant, the x is positive, but the y is negative. So if we use that and connect back to this sine, cosine, and tangent, if we're in the first quadrant where x's and y's are positive, that means that sine will have to be a positive number because y is positive. Cosine will have to be a positive number because x is positive, and tangent will have to be a positive number because y over x, y is positive and x is positive, so positive over positive is still positive. So in this first quadrant, all trig functions are positive, okay? Now, if we jump into the second quadrant, we have x is negative and y is positive. So right away we have that sine's going to be positive because it's a y value. Cosine will be negative because the x values are negative in the second quadrant. And then tangent, which is y over x, it's going to be a positive over a negative, which is going to be a negative. So in the second quadrant, only sine will be positive. And I say only sine, but also I mean, cosecant will also be positive because sine and cosecant are best friends. They're basically the same thing. So if sine's positive, cosecant's positive. In the third quadrant, we have x and y are both negative. So that means that both sine and cosine will be negative because both x and y are negative. But tangent will be positive because we'll have a negative y over a negative x. That's going to become positive. So down here we have that tangent's positive, and only tangent and cotangent will be positive here. We do the same exact idea in the fourth quadrant. The x values are positive, the y values are negative, so sine and tangent will be negative, and only cosine will be positive. So what this allows us to do now is to find sine, cosine, and tangent in any quadrant. We can figure out whether it would be positive or negative based off these x and y definitions. And we no longer are stuck using just triangles that exist between 0 and 90. We can start using triangles, that exist in other areas. So for example, we could get a triangle that's like right here, okay? And as long as we can figure out what this x and y are, then we'll be able to figure out what sine, cosine, and tangent are in this little triangle here. So that's like a huge advantage. And what we're going to use to help us out with this is the three triangles that we already know. And then we're going to take this stuff that we just figured out where they're positive, and we're going to make like a little acronym thingy. I never remember if acronym's the right name, but it's this little thing. We're going to say all students take calculus, or all students take classes, if you want to do it that way. So that's our little way of remembering this thing. So all students take, and then calculus is what we normally use in math, but some people like to use classes because it makes more sense. Students always take classes. They don't always take calculus. So all students take classes, and that says all of them are positive. Students, S, sine is positive. T, take, tangent's positive. C, classes or calculus, cosine's positive. So we're going to use that in addition to our little three triangles. So I'm just going to redraw them real quick. So we have our 30, and basically the faster you can redraw these, the better off you're going to be. But like I've said now a couple times, I would personally draw these in one place on a test and then not need to keep redrawing them and just reference back to them. But we're basically going to take this, all students take calculus, and these three triangles, and we're going to be able to solve for anything around the triangle. Following these three steps, we're going to figure out what quadrant our angle is in, and then we're going to determine whether it's positive or negative by using all students take calculus or all students take classes. We're going to figure out what the reference angle is for the angle that we have. Remember, reference angle is the shortest distance to the x-axis. And then we're going to use our SOHCAHTOA or our XY definitions to figure out what the actual angle is, basically. So let's start off with cosine of 150. So first thing we're going to do is just kind of draw where is 150. So if I draw 150, it's like right over here. Okay, so here's 150. And what that tells me is we're in quadrant 2. And if I'm working with cosine in quadrant 2 is going to be negative because of our all students take calculus, only sine is positive. And if we're working with cosine, that means that it's going to be negative here. Now, reference angle is going to be our shortest distance to the x-axis. So that's going to be right here, 30. Okay. And officially what we're doing is we're making a 30 triangle right here. Okay. So I'm going to show you this just once. I don't like to do this. Officially, that's what we got going on. This value would be negative because we're going left in the x direction, so negative. And then we could just do SOHCAHTOA with this. So cosine is going to be the adjacent, negative square root of 3 over the hypotenuse, 2. So we would have cosine of 150 is going to equal negative square root of 3 over 2. So if we use that little triangle, we've kind of filled in everything. But what I would suggest we do is we say, okay, it's a 30. Let me look at my 30 triangle up here and say, okay, cosine of a 30 would be the square root of 3 over 2. And then I know because it's in quadrant 2, it's negative. So my answer will be negative square root of 3 over 2. So I don't have to redraw this triangle every time. So let me show you with this guy over here. So I have cosecant of 120. We know that cosecant is really a sine. So we're really thinking about a sine value right this second. We have 120 would be right here. Its reference angle is going to be 60, okay? So I have that I am in quadrant 2, it's sine, so it's positive in quadrant 2, and its reference angle would be 60. So what I'm going to do is look at this triangle right here, and I'm going to say, hey, what is sine of 60 in this triangle? So sine of 60 is going to be a square root of 3 over 2, and then I know that it's positive in this quadrant. And that's going to be what, don't circle that, that's going to be what sine is, right? So sine of 120 is that. Now, they asked us for cosecant of 120, so we got to remember to flip this upside down. So we're going to have 2 over the square root of 3, which we have to rationalize as 2 rad 3 over 3. And so that's actually our answer here. So just because we're working with sine, we have to remember that we were really working with cosecant. We don't want to forget that. So that's my suggestion to you, is you basically figure out what quadrant you're in, which tells you whether your answer is positive or negative, and then you figure out your reference angle, and you use the reference triangle that we have drawn there to figure out what the sine, cosine, tangent value would be. And then we just kind of combine whether it's positive or negative with the answer using that reference triangle. All right, it's your turn. Try these ones out, see if you can figure it out. You should pause the video and then you can come back and fast forward a little bit to get to the answer if that's what you want, or skip the whole section if you're just like a super genius. Okay, hope you paused. We got cotan of 135. So first, cotan is really a tangent, and 135 is going to be in the second quadrant right here, 135. In the second quadrant, we know that tangent is negative using our little all students take calculus, only sine's positive in the second quadrant, so tangent will be negative. And our reference angle is 45, so that's how far away from the x-axis we are. So I'm going to use those reference triangles again. Now remember, I would have them drawn, so I wouldn't need to redraw them. I'm only going to draw the 45 right now. And so I would say, okay, tangent of a 45 would be 1. Okay, but I'm really doing cotan, so I'm going to flip that upside down. So I'm going to have that cotan of a 45 would normally equal just 1, but it's negative because I'm in the second quadrant. So cotan of 135 is just -1. Done. Same exact idea over here. We got to do cosine of 300. So we're going to figure out where 300 is. It's right here. It's 60 away from the x-axis. So in quadrant 4, cosine is positive. All students take classes. Cosine is positive, and the reference angle is 60. So I'm going to use my reference triangle for 60 up here. I'm going to say, hey, cosine of that would be 1/2, and I know that the answer is positive. So cosine of 300 degrees is going to be positive 1/2. Done. Right. When we're in radians, it's the exact same thing. It's just like a little bit trickier for some people because they don't know radians as well. But we are just going to figure out where 5 pi over 6 is. So I'm going to remind you that when we're counting by pi over 6, which is 30s, that's when we have 2 dots in the middle and then we land on the line. So I'm going to do 5 pi over 6 is going to be right here. So I'm in quadrant 2, and sine is positive in quadrant 2. Again, using our all students take calculus, sine s is positive. And our reference angle is pi over 6. Okay, now I want to remind you that if I give you something in radians, that your answer should be in radians if we're talking about an angle measurement. So the official answer is pi over 6, but we know that that's a 30. Okay, so what I'm going to do is look at my reference triangle for 30, and I'm going to say, hey, sine of 30 would be 1/2, and it's positive if I'm in the second quadrant. So that means that sine of 5 pi over 6 is going to be a positive 1/2. Same idea for cotan. When we go to do this one, we're counting by pi over 3s. That's the one where we have the one that makes 6 things, like a little hexagon shape. Okay, so I'm going to do 1, 2, 3, 4, 5. That's going to put me right here. So I'm really going all the way around here. So this is in quadrant 4. Cotan, which is really a tangent, is negative in quadrant 4. And our reference angle is pi over 3, aka 60. So I would just look at my 60 triangle and say, hey, tangent would have been the square root of 3 over 1. So cotangent is going to be 1 over the square root of 3, which we know we have to rationalize as square root of 3 over 3. And then it's negative because we know that it's negative. And so we get that cotan of 5 pi over 3 is going to be a negative square root of 3 over 3. So I hope you're kind of getting the trick here, basically, right? We need to figure out what quadrant it is to figure out if we're positive or negative, and then we just figure out the reference angle, and then we use the reference triangle to figure out sine, cosine, tangent, and then we just combine the two and make it positive or negative, whatever answer we got using the triangle. All right, it is your turn. You should pause the video and you should try this yourself so that you can make sure that you're a genius and you know how to do everything. And then you can unpause and follow along. Yeah, tangent 2 pi over 3. So 2 pi over 3 is going to be right here. That's quadrant 2. And tangent is negative in this quadrant. The reference angle is pi over 3, aka 60. So if I had my 60 triangle drawn somewhere, so I didn't need to redraw it every single time, I would look at that and say, hey, tangent of a 60 is going to be a square root of 3. And I know that it's negative, so I just combine them. For this one, secant, I know that that's really a cosine. 3 pi over 4, so the pi over 4s fall right in the center and on the edge, on the axis. So I'm going to have right there 1, 2, 3 pi over 4s. So that's in quadrant 2. Cosine is negative in quadrant 2, and my reference angle is pi over 4, aka 45. So I would look at my reference triangle for a 45, and I would say, hey, secant, which is really cosine. Cosine would be a 1 over the square root of 2, but I want secant, so I'm going to flip that upside down. So square root of 2 over 1, and I know that it's negative. And so my answer would just be a negative square root of 2. I hope that's making a tiny bit of sense to you and that you can see that you can answer these really quickly. You just have to figure out what quadrant you're in and what your reference angle is. Now, for these examples, things are a little bit different because we fall on the axes. So when we have quadrantal angles, which remember is when we're at like 0, 90, 180, 270, 360, et cetera, et cetera, et cetera. What we're going to use is the XY definition. So we're going to say, hey, I know sine is really a Y value. I know cosine is really an X value. And I know tangent, which is sine over cosine, is really Y over X. And that's just talking about the thing that we did way up here in the beginning, right? We have here in the purple, sine is Y, cosine's X, and tangent is Y over X. So if we keep that in mind, we're going to be able to figure this out. So sine of pi over 2. So first thing I'm going to do is just graph pi over 2. So pi over 2 is right here. And what we're going to do is we're going to make this a point. We're going to make it the easiest possible point. So if I go in this direction, I'm going 0 in the x direction, and I'm going just some value in the y direction. And we're just going to let that value be 1, which is just like the easiest number to work with, right? 0 and 1, the two easiest numbers. So I'm going pi over 2, and it's at this point 0, comma 1. Now, sine is a y value. So now I literally just look at the y value of this point and say, okay, what's the y value? The y value is 1, so sine of pi over 2 is 1 because sine is the y value, and we can use that little point. Tangent, 3 pi over 2. So we have 3 pi over 2 is going to be way down here. And we're going to do the same exact idea. We're going to say, hey, an x value would be 0, and I'm going down, so my y value would be negative something, and we're just going to let it be negative 1 because that's, again, 0 and 1, easiest points to work with. And tangent is y over x. So if I have tangent of 3 pi over 2, I'm going to take the y value, which is negative 1, and the x value, which is 0. But we know that we're not allowed to divide by 0 in math, so the answer to this is actually undefined because we don't have a definition for what divide by 0 is. Okay, does not exist, or no solution. It's undefined because we don't have a definition for divide by 0. So no definition, undefined, no defined. All right. So undefined. So whenever you fall on the axes, you're just going to use the XY definition. All right, you should pause the video so that you can try this yourself. I know you didn't pause the video. It's okay. I'll forgive you. Pi is going to be chilling way over here. This time I'm going negative 1 in the x direction and 0 in the y. So again, negative because I'm going to the left. And I'm just going to use the easiest numbers, 0s and 1s. Now, secant is really a cosine flipped upside down, and cosine is really x. So this is going to be 1 over x. So when I look at this point, my x value is negative 1, so I'm going to have a 1 over negative 1, so negative 1. So secant of pi is going to be negative 1. For this one, we're at sine of 0. That's going to be right here. So that's going to be over 1 in the x direction and up 0 in the y direction. Sine is the y value. So sine of 0 is going to be 0. And there you have it. That's basically the idea. So when you're doing all of these things, you're going to figure out the quadrant, figure out the sine, figure out the reference angle, use the reference triangle, and then combine. Now, eventually, I'm trying to look to see if I did it in any of these ones. I didn't. On a test or quiz, I'm not going to give you all this extra bit of information here, right? Like I would just ask you, what is cotangent of 11 pi over 6? And I wouldn't give you any of this. So you have to start recognizing that you need to know the quadrant it's in so you can figure out whether it's positive or negative, and you need to know its reference angle so you know which triangle to work with. Or if it's a quadrantal angle, you need to know the XY definitions for sine and cosine. All right. So this is just like because it's day 1 and we're trying to figure it out, but in future days and on the test, I would not give you all of this like extra support here. You would have to know to find the quadrant, the sine, and the reference angle to figure out how to solve this in both degrees and radians. All right, I hope that was clear. We'll go over any questions next class, and I'll see you next time. Bye.